4 minutes. That is the number nobody is talking about. Not 4 hours, not 4 days. 4 minutes of complete, total, absolute silence. No signal, no telemetry, no voice contact, no data, nothing. And during those 4 minutes, 3 human beings are sitting inside a capsule, 239,000 miles from Earth, with $93 billion of American taxpayer money strapped to their backs. And NASA cannot hear a single word they say. This is not a malfunction. This is not a technical glitch that engineers are scrambling to fix. This is a designed condition of the most expensive space program in human history. Every single time an Artemis crew passes behind the moon, they vanish. Completely. The far side of the moon blocks every radio frequency known to science. The laws of physics do not negotiate. The signal dies. And for 4 minutes, the crew is entirely and completely alone. Cable news is not running the story. The press conferences are not leading with it. The NASA administrator is not standing at a podium explaining what 4 minutes of total communication blackout actually means when something goes catastrophically wrong at the 2-minute mark. I'm going to show you exactly why they are not talking about it, because the reason is mathematical, it is institutional, and it is extraordinary. I am Daniel, this is Rolex Economics, and today we are going to run the numbers. Here is what the official story looks like. The Artemis program is America's return to the moon. It is the most ambitious human spaceflight initiative since Apollo. It involves the most powerful rocket ever built, the Space Launch System, which generates 8.8 million pounds of thrust at liftoff. It involves the Orion capsule, engineered to sustain human life across deep space missions. It involves the Gateway Lunar Space Station, designed to serve as a permanent crewed outpost in lunar orbit. The hardware is genuinely extraordinary. The ambition is genuinely historic. The price tag to date is $93 billion. That number comes directly from NASA's own Inspector General. $93 billion across development contracts, launch infrastructure, mission operations, and program management. To put that in perspective, that is more than the entire GDP of Bulgaria. It is more than Apple spent on research and development across the last 4 years combined. It is the single largest investment in human space exploration ever made by any nation in the history of civilization. And inside that $93 billion program, for every single farside lunar pass, there is a 4-minute window where the crew could be dying and NASA would not know. The flight controllers in Houston would be sitting at their consoles watching a flat line on their telemetry screens. The communications officers would have nothing in their headsets. There would be no voice, no data, no heartbeat monitors, no cabin pressure readings. And there is nothing, absolutely nothing, they could do about it until the capsule clears the far side horizon and the signal comes back. Run the numbers. $93 billion invested. 4 minutes of zero communication redundancy per far side pass. Zero relay infrastructure currently deployed above the lunar far side. That ratio is the number that every aerospace engineer, every mission planner, and every senior NASA administrator has stared at in silence. And the question it forces is brutally simple. How does a $93 billion program not solve a 4-minute communication gap? Stay with me, because this is where it gets extraordinary. The fix is known. It has been known for decades. It is not experimental. It is not theoretical. It does not require a breakthrough in physics or a new generation of propulsion technology. The solution is a relay satellite. A single communications satellite positioned in a halo orbit above the lunar far side can simultaneously see both the crew on the surface and mission control on Earth. One satellite, continuous contact. The 4-minute blackout window disappears permanently. The cost of that satellite is approximately $300 million. $300 million is the engineering estimate for a communications relay in lunar halo orbit, inclusive of development, launch, and 5 years of operational support. $300 million. Against a $93 billion program budget, that is 0.32%. It is a rounding error. It is less than what NASA spends on program management overhead in a single fiscal quarter. The math here is not complicated, and it is not close. $300 million to permanently eliminate the single most dangerous known gap in crew safety for the entire Artemis program, and it has not been funded. The relay satellite is not in the current Artemis architecture. It appears in long-range planning documents. It shows up in capability roadmaps for future Gateway operations. But for the near-term crewed missions, for the astronauts who are preparing right now to go to the moon, the 4-minute blackout is still there. It is baked into the mission profile. It is an accepted condition. This is where I need you to understand what accepted condition actually means in operational terms. In commercial aviation, a 4-minute window where air traffic control loses all contact with a passenger aircraft is a Category A emergency. Protocols activate the moment contact drops. Every asset in the region is redirected. The incident generates federal investigations, mandatory regulatory reviews, and infrastructure upgrade requirements, regardless of whether anything actually went wrong. The loss of contact itself is treated as the emergency. In the Artemis program, the loss of contact is the schedule. It is a recurring, predictable, documented event that mission planners build their timelines around rather than eliminate. The difference between aviation and Artemis is not the severity of the risk. A crew capsule behind the moon is in a more dangerous communication environment than any commercial aircraft ever placed in service. The difference is institutional. Aviation has a regulator with enforcement authority. NASA, in the context of its own human spaceflight risk decisions, is effectively its own regulator. Here is the deeper number. The Apollo program accepted far-side communication blackouts because it had no choice. The technology to build and deploy a lunar relay satellite in 1969 existed in theory, but not in practical form at Apollo mission timelines. Neil Armstrong and Buzz Aldrin went dark behind the moon because the alternative was not flying at all. That was 1969. The year is now 2026. The technology to solve this problem has existed for decades. GPS satellites operate on directly analogous relay principles. Geosynchronous communication satellites have provided continuous global coverage since the 1970s. The relay architecture for lunar far-side communication is not an unsolved engineering problem. It is an unfunded budget line. Run those numbers again. 1969, the technology did not exist. 2026, the technology exists, has existed for decades, costs $300 million against a $93 billion program. And the 4-minute blackout is still there. That is not a technology story. That is a priority story. That is an institutional decision story. And it is the story that nobody is running right now. So what actually happened? Because NASA did not forget about relay satellites. The engineers who designed the Artemis communication architecture are not unaware that the far side of the moon blocks radio signals. Something else happened inside the budget process, something that cuts far deeper than a technical oversight. The Artemis program was built inside a political and budgetary framework where the relay satellite kept losing the prioritization argument to hardware that produces photographs and press conferences. The Space Launch System produces a visible launch event. It generates footage that plays on every news channel. The Orion capsule produces a visible splashdown. It generates footage that plays on every news channel. A communications relay satellite in a lunar halo orbit produces continuous telemetry coverage for a 4-minute window that the public will never see, cannot photograph from Earth, and will not understand unless something goes catastrophically wrong inside it. Bureaucracies optimize for visibility. The relay satellite is invisible infrastructure. Invisible infrastructure loses budget arguments inside political systems. This is what program managers call a risk normalization failure. When a known risk is present from the beginning of a program and the program proceeds anyway, the risk does not disappear. It gets normalized. It becomes background noise. It becomes an accepted condition. It becomes the 4-minute blackout that mission planners build their schedules around. And once a risk is normalized inside a $93 billion program with thousands of employees and decades of accumulated institutional momentum, the activation energy required to unnormalize it becomes enormous. Now here's the number that changes everything you have heard so far. China launched a relay satellite called Queqiao in May of 2018. The satellite cost approximately $500 million inclusive of full development and launch. It was positioned in a halo orbit above the lunar far side. It provided continuous, uninterrupted communication coverage for the Chang'e 4 lander, which became the first spacecraft in human history to successfully land on the far side of the moon in January of 2019. Chang'e 4 is still operating today. Queqiao is still relaying its data back to Earth right now. China identified the relay satellite as a prerequisite for far-side operations. Not a future capability, not a long-range planning item. A prerequisite. They built the relay infrastructure first. They launched the satellite before the lander. The lander arrived at the far side of the moon with full, continuous communication coverage from the moment it departed Earth. The 4-minute blackout problem did not exist for Chang'e 4 because China made a decision at the program architecture level that it would not exist. They funded it, built it, launched it, and it worked. The United States is preparing to send human beings to the lunar far side under the Artemis program. China sent a robotic lander to the lunar far side with complete communication redundancy 7 years ago. The comparison is not comfortable for anyone in a NASA press office, but the comparison is the story. It demonstrates conclusively that the relay architecture is solved, the technology is proven in lunar operational conditions, the cost is thoroughly understood, and the decision not to deploy a relay satellite for Artemis crewed missions is a deliberate institutional choice, not an engineering constraint. Stay with me because this is where the numbers come back to you personally. The federal government spent more on Air Force One upgrades in the last budget cycle than the total cost of a lunar relay satellite. The federal government spends more on congressional office operational budgets annually than the $300 million figure for a relay satellite with 5 years of operational life. The math of what was funded versus what was not funded is a list that does not reflect well on the institutions making the prioritization decisions. You personally paid for part of this program. Every American taxpayer has contributed to the $93 billion Artemis budget through federal tax allocation. The per capita share of the full Artemis program cost across the American taxpayer base is approximately $279 per person. The per capita share of the $300 million relay satellite across that same taxpayer base is less than 91 cents. Less than $1 per American taxpayer would fund the infrastructure that permanently eliminates the 4-minute window where the crew is unreachable. The institutional cost calculation of getting this wrong is not a number anyone at NASA wants to discuss in a press briefing. But the number exists, and it is not theoretical. The Challenger disaster cost the American space program approximately $32 billion in today's adjusted figures across the 2-year stand-down, the full vehicle redesign program, and the extended congressional investigation. The Columbia disaster cost a comparable institutional figure. A crew loss event during a 4-minute far-side communication blackout, where the cause cannot be determined in real time and mission controllers have no ability to intervene, would be categorically different in its institutional aftermath. The investigation would ask one sequence of questions before any other. Did NASA know the communication gap existed before the mission launched? The answer is yes. It is documented in mission planning materials. Did NASA know the gap could be eliminated with existing technology? The answer is yes. China demonstrated it operationally in 2018. Did NASA allocate the funding to eliminate the gap before scheduling crews into the environment where the gap exists? The answer is currently no. That sequence, delivered under oath in a congressional hearing after a crew loss event, would not produce a survival institutional outcome for the program as it currently exists. $300 million is not a large number in the context of what it is protecting. It is protecting the $93 billion already invested. It is protecting the careers of every NASA employee and contractor working on Artemis. It is protecting the political capital of every member of Congress whose district contains an Artemis program facility. It is protecting American credibility in the single most consequential technological competition of this century against a China that already solved the same problem 7 years ago. And it is protecting the lives of the crew members who are going to enter that 4-minute window. The 4-minute blackout is not a mystery. It is not classified information. It is documented in mission architecture reviews, in the NASA Office of Inspector General annual reports, in academic analyses of the Artemis communication architecture that are freely available. The gap is known, the fix is known, the cost is known. The proven solution is deployed and operating on the far side of the moon right now on a Chinese mission. What is not publicly explained is why, with $93 billion committed and human lives being scheduled into the blackout window, the $300 million line item has not been treated as the non-negotiable safety prerequisite it is. There is no recovering from this data point once the crew is in that window. The moment Artemis astronauts cross behind the moon and the signal drops, the 4 minutes begin. Everything that happens inside those 4 minutes is entirely on the crew. Mission Control will be watching a flat telemetry line. If those 4 minutes ever end with something other than a recovered signal on the other side, the question that follows will define American space policy and institutional accountability for decades. How did the most expensive space program ever built send human beings somewhere it could not hear them? The math is always the story. $93 billion invested in the program. $300 million to permanently close the communication gap. 0 relay infrastructure currently deployed. 4 minutes of total silence per far side pass. And China built, funded, launched, and successfully operated the exact solution 7 years ago before they sent a single spacecraft to the far side of the moon. Run those numbers. Write them down. Share this, because the people around you are about to watch a launch, and they will have absolutely no idea what happens when the signal disappears. I am Daniel. This is Rolex Economics. I will see you in the next one.